You've heard it your whole life, right? Eat your carrots, they're good for your eyes. But have you ever really stopped to wonder why? What's actually happening on a molecular level? Well, it turns out it's this incredible story of a chemical journey that starts with a vegetable and ends with you being able to see in the dark. So let's get into it.
So, what is the real story here? What's the connection between a carrot and your vision? The answer is a fascinating trip, from a simple pigment in a plant all the way through your body to a tiny light-sensitive switch flicking on and off inside your eyes.
Okay, so our story actually begins before we even get to vitamin A itself. It starts with the raw material, the precursor that our body uses to make it. And that whole process kicks off inside plants, with the very thing that gives a carrot its bright signature color. And here it is, beta-carotene. This is the pigment that makes carrots orange. But what's really cool is its structure. If you look closely, you can see it's basically made of two identical halves, joined in the middle. And that's the key, because when our body gets a hold of it, an enzyme can literally snip it right down the center, giving us 2 molecules of vitamin A for the price of 1. Pretty efficient, huh?
So how does that all happen? Well, when you eat something like a carrot, enzymes in your intestine get to work, chopping that beta-carotene in half to create something called retinol, which is a form of vitamin A. Now, since vitamin A is fat-soluble, it gets absorbed right along with the fats in your meal. Then it's all packaged up and sent on its way through your bloodstream. And its main destination, your liver.
Think of your liver as the body's high-security vault for vitamin A. It takes what it receives, converts it into a really stable form called retinol palmitate, and just keeps it on reserve. And this system is incredibly good at its job. I mean, in a healthy adult, these stores can last for 1 to 2 years, giving you a steady supply whenever your body needs it.
Okay, so we've got all this vitamin A stored up and ready to go. Now we get to the really amazing part. How does this one molecule actually let us see? It all comes down to its job as a tiny, light-activated switch in the back of our eyes.
Deep inside the rod cells of your retina, those are the cells that handle your vision in low light, there's this special pigment called rhodopsin. Rhodopsin is made of 2 parts, a protein called opsin and a very specific, kind of bent form of vitamin A called 11-cis-retinol. And this little molecule, well, it's the real star of the show. So when you're in the dark, this vitamin A molecule is in its off position. It has this little kink or a bend in its structure. In this bent shape, it fits perfectly inside that opsin protein, just sitting there, primed and waiting. The whole system is basically armed and ready for action.
And then, bam, a single photon of light comes into your eye and hits that rhodopsin molecule. That one tiny burst of energy is all it takes to make the bent vitamin A molecule instantly snap straight. It transforms into what we call all-trans-retinol. This physical shapeshift is the trigger. It's literally the flick of the light switch.
So what does that shape-shifting actually do? Well, when the molecule straightens out, it forces the whole rhodopsin protein to change its shape too. This kicks off a super fast chain reaction that slams shut the sodium channels on the cell's surface. That change in the cell's electrical charge is the signal. It's the message that zips up your optic nerve to your brain, which then interprets it as one simple thing: light. This whole process happens millions of times a second without you even thinking about it. But what happens if you don't have enough vitamin A to keep those rhodopsin molecules supplied and ready to go? Well, the system starts to break down, and the consequences can be pretty severe.
The very first classic symptom is night blindness. Makes sense, right? Without enough vitamin A, your rod cells can't rebuild that rhodopsin quickly, so it's really hard for your eyes to adjust to low light. If the deficiency gets worse, it can lead to severe eye dryness, a condition called xerophthalmia, and even corneal ulcers. And it doesn't stop there. It can also mess with your skin and weaken your immune system.
In the absolute worst-case scenarios, a condition called keratomalacia can happen. And this quote from the source material, it really captures just how bad it can get. The cornea can literally soften and degrade, leading to permanent blindness. It's a really stark reminder of just how critical this one single nutrient is.
And yeah, beyond the eyes, a deficiency really shows up on your skin. Vitamin A is absolutely essential for your skin cells to grow and develop normally. Without it, you can get something called follicular hyperkeratosis, also known as phrenoderma or toad skin, where the skin gets dry, rough, and bumpy just because new skin cells aren't forming the way they're supposed to.
Okay, so that all sounds pretty scary. But the good news is that vitamin A deficiency is totally detectable and preventable. So how do we spot it? And more importantly, how do we make sure we're getting enough to keep those molecular light switches working?
One of the simplest ways to diagnose a deficiency is with a dark adaptation test. It's actually really intuitive. A person is exposed to a bright light for a bit, and then they're moved into a dark room. The doctor just measures how long it takes for their vision to adjust. For someone with a vitamin A deficiency, that time is way, way longer because their rhodopsin just isn't regenerating efficiently. And preventing it all comes down to diet. You can get vitamin A in two main ways. From animal sources, like liver, egg yolks, and dairy, you get preformed vitamin A, or retinol. And from plant sources, you get provitamin A, like that beta-carotene we started with, in colorful foods like carrots, pumpkin, dark leafy greens, and bell peppers.
So how much do you actually need? Well, to give you a solid target, the recommended daily allowance, or RDA, for adult men is 900 micrograms a day. For adult women, it's 700. And while that might sound like a lot, it's actually very achievable with a healthy, balanced diet. So there you have it. From a simple pigment in a carrot to a complex signal in your brain. The story of vitamin A is just a perfect example of the incredible power that's hidden in the food we eat. And it kind of leaves you with a final thought. If just one molecule can do all of this, what other amazing molecular keys to our health are just waiting to be discovered on our plates?